Director of Engineering at Meta AI, who has taken the trouble of joining, presenting this topic in spite of the big difference in time zones. So we would like to welcome him and thank him for accepting the invitation. I would also like to thank the distinguished participants to this particular webinar. Like the president of IIPT, I see that he has also joined the meeting. So I would like to welcome all the distinguished participants from different parts of India. As you know, we have been holding these webinars since October 2023, almost every Sunday, with the intention of educating our members and students about various topics that may not be familiar to them, okay, in their regular courses and regular studies. It's a kind of a continuing education program for all of us. We have been helped in this endeavor by faculty members from colleges, universities, and research institutes from all over India on various topics. Our goal is regular studies. Our goal is education program for all of us. We have been helped in this endeavor by faculty members in colleges, universities, and research institutes all over India. Raman, please take care of the problem here. Raman, please take care.
Sir, can you give me the host?
Host, I am the host.
Can you give me co-host, sir?
Co-host is Sridhar. Okay, just please wait. I can't do that. Please, I will ask Sudha to do it. So we have been helped in this endeavor by so many people. Our goal is really to arrange one talk at least by 1 year by each member of KPA. That's our goal. And we wish to connect as many physics faculty members and students as possible in Karnataka and even from outside the state. So these are our objectives, and we have been doing this for the past 1.5 years, and we have been successful. And today we have a very distinguished speaker from USA, who is the Director of Engineering from Meta. He is going to present a talk about artificial intelligence and its applications. So before I request him to speak, I would request our member, Dr. Kenneth, to introduce the speaker briefly. Over to Kenneth.
Hello, Sridhar, please. Sridhar is on.
Yeah, please introduce.
Yes, I'm here. Right. ಎಲ್ಲರಿಗೂ ನಮಸ್ಕಾರಗಳು. ಸೊ ಕಾಲೇಜಸ್ ಪ್ಲೀಸ್ ನೀವು ಮ್ಯೂಟ್ ಮಾಡಬೇಕು.
ಕಾಲೇಜ್ನವರೆಲ್ಲ ಕೊಡಬಾರ್ದು.
ಕಾಲೇಜ್ನವ್ರಲ್ಲ ಇರ್ಲಿ ಬಿಡ್ರಿ ತೋರಿಸ್ರಿ, ಬಟ್ ಪ್ಲೀಸ್ ಯು ಮ್ಯೂಟ್ ದಟ್. ಬಹಳ ಗಲಾಟೆ ಆಗ್ತಾ ಇದೆ, ಮ್ಯೂಟ್ ಮಾಡ್ರಿ ನಿಮ್ಮ ಇದನ್ನ.
ಯಾರು ಮಾತಾಡ್ತಾ ಇರೋ ಎಲ್ಲ ಮ್ಯೂಟ್ ಮಾಡ್ಕೋಬೇಕು. ಈಗ ವೆಬಿನಾರ್ ಸ್ಟಾರ್ಟ್ ಆಗಿಬಿಟ್ಟಿದೆ. ಡೋಂಟ್ ಟಾಕ್ ನೌ ಪ್ಲೀಸ್.
Okay. So good morning to all who have joined this webinar, and good evening to our distinguished guest speaker, Mr. Sridhar Iyer, who is speaking to us from Seattle, USA. It's my proud privilege to introduce our distinguished guest, Mr. Sridhar Iyer, because he is from Karnataka and from my city, Raichur. He is the son of my teacher and later my colleague, Professor R. Krishnamurthy. Born in 1979, after his primary education in Raichur, Mr. Sridhar joined Chinese School, Bijapur, where he completed his school and intermediate education. And I think the Chinese school education taught him discipline, dedication, sincerity, and hard work to achieve goals. After intermediate, he joined NIT, Motilal Nehru National Institute of Technology, NIT, Allahabad, now Prayagraj, and completed his BTech degree in flying colors. Due to his brilliant academics, he was offered MSc with a scholarship at the A&M University, Texas, where he completed his master's. And after master's, he joined Microsoft and worked for more than 10 years in different capacities and contributed in the development of the software Windows and also the Bing search engine technologies. Next, he worked as a head of revenue platforms at Twitter, overseeing engineering for their revenue products. Okay, and next, in 2018, he joined Facebook, now Meta, as the director of engineering leading the communities team and developing products to foster online communities. As the director of engineering, he worked for Instagram Reels team, where he focused on enhancing short film video experiences. And now he is working with Meta AI Assistant app. And recently, he led the launch of the Meta AI Assistant app. Since he is involved in directly making this AI app, I thought that it's a right choice and to request him to address our gathering, because so far we have addressed, our KPA has been addressed by the people who are indirectly involved in this, but now directly we can hear from the horse's mouth. Okay, so actually he is presently settled in Seattle area with his family, and he is passionate about making technology, especially artificial intelligence AI, more human and more useful and more empowering for people everywhere. An optimist at heart, Mr. Sridhar believes in the power of technology and AI to transform human lives for the better. On behalf of all of us, I wish Sridhar to excel in his field and achieve all his goals. All the best, Sridhar. Here, I take this opportunity to thank Professor R. Krishnamurthy for helping us in arranging this webinar. Thank you all for the patient hearing. Thanks.
Now, over to Dr. Sridhar, you may start the presentation.
Thank you. Sri Gurubhyo Namaha. Thank you very much, everybody, for inviting me to this, and thanks for that wonderful introduction. I think Sri Kenneth was a little too generous in the way that he introduced me, but that's, I think, the mark of a teacher who is always of high praise for other people. It's actually a very high privilege and pleasure for me to address this gathering of people, specifically with so many teachers and so many students. My dad is also a physics professor, so this community is especially close to my heart. So today we are going to talk about a topic that is undoubtedly on the minds of a lot of people, which is AI, or artificial intelligence. There is perhaps nobody in this world right now who has not heard about AI, or who has not seen utility of AI, or who is not wondering how AI might affect their fields. And so, it was a very good opportunity, as well as something of my passion, to come talk to all of you about what AI is, how do we understand how this thing works, and what should we know? How do we use this in teaching? How do we use this in research? And if I'm a student, how do I use AI? And as I was talking to Sri Kenneth about setting up this talk, he encouraged me to sort of make this talk a little bit more popular science version versus a very hardcore engineering talk. So I have structured this talk as a very high-level introduction to artificial intelligence. So I'm hoping that at the end of this talk, all of you will understand broadly what AI is, and also sort of understand all the steps that it takes to build AI. This will not go into the details of building, but I'm very happy to add those details if there are any questions after the talk is done. And we will also structure some demos in this thing, though I'll actually be able to show you how things work. So hopefully that's also interesting for people to see. So without much ado, let's start the discussion. I'll just go through a quick outline of what I'm going to talk about. So we'll talk about what AI is, and why there is so much hype. Like suddenly in the last so many years, we've been starting to hear AI, and ChatGPT, Claude, and Gemini, and all of these things are all over the place. What led to this hype, and why is AI so popular today, and what made it popular? And then, of course, how AI is built. I'll spend a good amount of my talk on this one. And then, of course, we'll talk also an equally good amount on the applications of AI in research. And we'll go through some examples of how AI is affecting multiple fields. I picked some fields from physics because it's close to people in this audience, but we'll also talk about other fields. And then we talk a lot about what AI is. We should also cover what AI is not, and what are the limitations and pitfalls of AI? Where should I be careful about using AI? And then, of course, we'll do some Q&A. So the first thing I want to do is actually start with a story, a true story. So the year is 2016, and there is a company called DeepMind. This company was later acquired by Google. And what you see on the screen right now is a board called the Go board. This is a game called Go. It's not as popular in India as it is in the rest of Asia. But this game is a little bit like chess. You can see all these pieces on this board that need to move in a particular set of moves. And it's a very complex game. It takes a lot of intelligence, a lot of intuition, a lot of pattern matching and skill to play. Some people say that it's actually much more complicated than chess. And in fact, there are more moves totally in the game of Go than there are atoms in the universe, apparently. So it's a very, very complicated game. And so in 2016, this company wrote a program called AlphaGo that was supposed to have some artificial intelligence to play this game of Go. And they set up this match, 5 games, which the reigning champion of the world of this game called this gentleman by name Lee Sedol. Lee Sedol was a Korean, and this game, I think, was held in Korea. And a lot of people were very excited about seeing these 5 games. There were, big TVs that were set up in the town square so that people can watch this game from wherever they are. The game was being live streamed and on television and everything like that. And people obviously did not believe that the computer can defeat a human in this game because of what I just said. This game takes so much of intelligence and so much practice and skill to master all the different facets of this game. And then game 1 started, and suddenly this program started making really aggressive moves. And Mr. Lee Sedol, who was the reigning champion, the world champion, was taken aback. And he was surprised by the moves that this program made. And he kind of lost his balance a little bit. And he lost the first game. And that sent shockwaves to people. And they were like, wow, this computer program is actually defeating the world champion. That's amazing. But always the thinking was that, well, it's a computer. It can actually do so many more computations per second than a human can ever do, right? So there is a brute force way of playing the game when you can look at every single move that you can make and pick the best move possible. So everybody was like ready for game number 2. And suddenly the game number 2 started. And after a bunch of moves, there was one move, I think it was move 37. I picked this screenshot from a YouTube video that shows this particular game. And that move, number 37, was something that surprised everybody. Like, you know how when there is chess championships that Gukesh or Vishwanathan Anand or some of these people play, there is commentary that's going on from other experts. So there was also commentary that's going on when this game was being played. And all of the experts looked at this move and they said, well, this is not a great move at all. Why would the computer play this move? This move should not be done. And nobody believed it. Even Mr. Lee Sedol, when he looked at that game, that move, he was surprised and like shocked that like this move does not seem to be, something that I would do at all. And then he walked off the game for a little bit to think. And when he came back, he realized a very brilliant move. And it was such a brilliant move that ultimately it was something that nobody could think about, but the computer won this game also. Now, at this point, people looked at this game a little differently, right? They not only knew that this computer could play a better game, they knew that this computer could make moves that nobody else can actually think about, even the world champion at that point of time. Now, obviously, this put Mr. Lee Sedol in a little bit of a back foot position, and he lost that game as well. Now, game 2, also, the computer won. And game 3 was a much bigger fight, but the machine still won that game. Game 4 was something that Lee Sedol actually won. So that was seen as a big triumph because this computer was like so good. This computer program was so good at playing this game that people did not assume that the humans could win again. But Lee Sedol actually won that game. And game 5, again, the computer won, right? So ultimately, I picked this example because in 2016, there had already been computer games. Like I think in 1997 or 1998, Gary Kasparov, the world's chess champion, played against the IBM program, on chess. And I think he won some games, the computer won some games. So this was already a thing. But this one had not just learned to play like us. It felt as though AlphaGo had learned to play beyond us. That AlphaGo was playing moves that we could not have seen. So the question is this just copying us? Is this actually thinking? Is this intelligent? Was this just following some patterns and mimicking? Was it a matter of chance that it picked the best moves? Now, I'll talk a little bit about a bunch of this in this talk, and hopefully this sets the stage for people to understand what AI is and why this is important. But this was one of those seminal moments that established AI as a force of nature, right? This is when AI actually came up in scale in front of people. And it showed us that it's not just brute force. And brute force means in a chess game, if I make a move, there are probably like 100 other moves that somebody else could make. And so a computer could compute every single move for every single combination and pick the best one. That's called brute force. But in this game, it'll be too many such combinations. And the computer did not just always pick the move that humans thought was the best. It picked, like in game number two, the move that was very surprising, but turned out to be the best move. So it was very creative and unconventional in the way that this AI played the game. So this ushered in this era of AI, and since then, AI has snowballed and like grown and exponentially actually grown at this point into being this thing that today we all look and wonder at, right? So the question is like, what is artificial intelligence? And this is not a textbook definition of it, but I thought I'd just give you like in plain simple words. It's just a name that we've given to a program or software that can actually perform tasks that we typically tend to associate with human intelligence. If we see something happening with the program and then we see, wow, that was actually very interesting. How did it come up with that? Like I would have not thought about it. Then that's kind of what we call AI. And then I have a question, actually, maybe people can hold their hands up. How many of you have used AI today? I know it's 10:30, you've all been awake for a few hours this morning. How many of you have used AI today? Just maybe use the Zoom control and like raise your hands.
I don't know whether they can do that.
Yeah. Well, I see a few people like Dr. Aluwalia raising his hand. But anyway, um, I would actually posit that literally everybody probably used AI today. If you have unlocked your phone with a Face ID, you've used AI. If Netflix has recommended a movie or a program, you've used AI. If you used Google search and it auto-completed a search query, you've used AI. And if you've used Instagram or Facebook in any way or form, you've used AI. So AI is very pervasive, even if you don't actually see it. You don't have to use ChatGPT to use AI. It actually is working behind the scenes to give you what you need. So that is literally that pervasive. But the question is like, why is there this boom today? Like, what led to this thing where everybody is now talking about AI and why is this all over the place? And I think there's a few things that led to this boom at this point. Number one is the amount of data that we have ready to train. There's a preponderance of data. There's an infinite amount of data on the internet that over the last decade or two, humans have figured out how to leverage all that data. How can I crawl and use all of this petabytes and petabytes of information, trillions of web pages? So that's big data is one big reason. The second thing is availability of new hardware that can do a lot of computations per second. You know, hardware is like CPU, right? Like anybody who's used a computer knows that there is a CPU chip that does a lot of computations and calculations on it. So there's something called a GPU, which is a graphics processor that turns out to be very, very good at doing parallel processing operations. And so when those hard pieces of hardware started coming out, it became much more easier to do like heavily compute heavy operations. So that's another reason. The third reason is actually the evolution, the development of new algorithms. There is an algorithm called the transformer. You don't need to understand what this is. I will visit this in brief during the talk, but know that there is an algorithm called the transformer, and then there's more since then that actually is the one that led to this particular boom in AI. And finally, there's an emergence of many, many, many models. ChatGPT, a lot of people might have heard. Claude is another model developed by a company called Anthropic. Gemini is a model developed by Google, Llama by Meta and Mistral, and so on and so forth. And some of these are open source. And open source means you can take this model that Meta develops called Llama, and you can use it for yourself, and you can train on that. So this democratizes the technology, and it puts this technology in the hands of everybody. And so when you do that, you know, the technology grows exponentially. And so essentially, it's just more compute, more data, and better math, honestly, is what led to this boom in AI. And when we talk about AI, one of the things that we always talk about is this thing called LLM, or large language models. So ChatGPT or GPT that you use is actually called an LLM, or a large language model. This large language model actually understands language. It understands concepts and context behind language. It understands how to reason and how to code and do all of these other things. And this is also another term that you'll use very, very often and hear very often in the AI world. And that's also led to is one of those big breakthroughs. Now, this is an example of, ChatGPT, where, I asked ChatGPT, explain the first law of thermodynamics in simple terms without using math. And then you can see how it explained it in very, very simple terms that anybody can understand. Energy can neither be created nor be destroyed, and it can only change forms from one form to the other. And then it also gives an example of like money in a bank account. You can take your money and give it to somebody else, but the overall amount of money in circulation is still the same. Which is amazing because it did exactly what I asked it to. It did not just give me the definition; it gave me in very simple terms. Now, in fact, like maybe let's do a quick demo. So if this is ChatGPT, can you all see this?
Yeah, we can see. Yeah.
Okay.
Yes, we
So
can.
let's do this one. So I can say, explain Newton's second law as though you were explaining it to a 10-year-old. Okay. So let's see. So it should really simplify it. It says it makes up a superhero story. It talks about how the ball goes and it has some momentum. Then it says, what is the law? It actually gives you the F equals m times a equation, and it gives a real-time example. Let's not go through this because for the sake of time, but you can see how it actually did exactly what I want. In fact, let's go one step further and see something really interesting. I can say, well, explain this to me through a small poem. So I asked it to write a poem and explain Newton's second law to me. And lo and behold, you have a poem there that says, if you push a thing, it starts to go. The harder you push, the faster it'll show. But if it's big, like a buffalo's bum, it won't move fast. It'll feel like a ton. And so on and so forth. It's fascinating. It's really, really fascinating how, a computer program can actually come up and do something like this. It made up this poem in like a fraction of a second. So then it becomes important for us to talk about the magic of LLMs. Like, what is an LLM? What is this thing they're trying to do, and what powers this thing behind it, right? And the magic of LLM is actually that ultimately this is the gist of it. They are just next word predictors. If you give them a sequence of words, it predicts the next word. It is just very good at predicting this. That's the only thing. So ultimately, when you all go and like think back to this talk and see what was this LLM, this is it. This is the at the core of what an LLM is. It's a next word prediction. Now, using this next word prediction, we can do a host of interesting things, but ultimately this is it. It's as simple as that. Now, you can all do this quick exercise in your minds. Energy can neither be created nor be destroyed, right? Everybody can know that. Jaisi karni, vaisi bharni, right? If you know how to read Hindi. And for those who know Kannada, we all know kaya kave kailasa, like Basavanna said. So if you give these sentences to an LLM, it will be able to predict what that next word is. But the more interesting thing about LLM is also that they are very good at capturing context. Because when you think about words in sentences, they mean a lot of things. So if you take these three sentences here and the word light in these sentences, they mean so many different things. In the first sentence, the bag was light indicates the weight of the bag. It was not heavy, it was light. In the second sentence, if you say, open the curtains and let some light come in, you're talking about illumination. You're talking about the light coming into the room. And then if you say, please light the lamp, this is a verb where you're asking somebody to strike a match and like go and light a lamp. The same word occurring in multiple different sentences have different meanings. And as humans, we have no trouble understanding this whatsoever. In Hindi, if you say, kal main aunga, then you know you're talking about tomorrow. But if you say kal main aaya tha, then you know that you're talking about yesterday in the same word kal. But that's because we learn as children, and then we have human intelligence and brains, and we have no trouble understanding this. But the question is, how do you make a computer understand this? LLMs are very, very good at understanding this context. So as we talk about LLM and AI, one of the other terms that I think people hear a lot is ML, or machine learning. I'm sure that a lot of people have heard this term too, or ML model or machine learning model. And what is machine learning? A machine learning is essentially one of the tools that is used for AI. It is the core tool that is used to train AI, right? And what does machine learning do? Machine learning approximates functions from data. Now, I'm getting slightly, very, very slightly technical here, but essentially, let's say you have a function f of x that maps x into a space y. Then in physics, you would derive a function like this based on first principles. So for example, if I came and told you, I see all these things that look like straight lines, can somebody come figure out what an equation of a straight line is? Now we know the equation of a straight line is y equals mx plus c. And the way that a physicist or a mathematician would go and define this and construct this is they would take the first principles. They say, okay, if there is a line, it intersects the x and y axis in a particular set of places. There is an intercept on the y-axis. Let's call it c because it's a constant and every line has a slope. And so they would go about reasoning it in that way, and they would arrive at this equation called y equals mx plus c. All they need is a set of descriptions of what you are trying to model. And once you have that description, they can use that first principles and their own intelligence and thinking in coming up with this equation. But machine learning works the other way around. For machine learning, if I give it a whole bunch of points, x, y coordinates, x1, y1, x2, y2, x3, y3, x4, y4, and if I give a million coordinates for that, it works backwards from that data and it guesses what could be the equation of the line that you want me to do with all these points. So essentially, while physics would be theory first, that you look at a hypothesis, you build a theory, and then you build equations from that theory, machine learning is data first. Machine learning looks at a whole bunch of data and tries to figure out what the function might be. Essentially, again, as we talked about just a couple of slides ago, AI is about prediction. AI is actually predicting what's the next word, what's the next thing. And it does this based on all of the training that it has been given with a lot of data. And like one of the key tools that we use called machine learning, indeed actually is used for prediction, but it also is used for learning, but it learns from the data and comes to the equation and not the other way around. So that's the main key message in this slide that I want people to take away, which is learning patterns from examples. That's what machine learning helps you do. Now, I think that it's time that now, with all this background, we should talk a little bit about how is AI built, actually, and what are the steps in building an AI. Again, as I said in the beginning of this lecture, I structured this in a very, very high level. So if some of you feel the lack of depth here, please contact me, and I'm happy to sort of have another session maybe to go into depth. But for now, let me stay a little bit of a high level. So there are two stages mainly in training AI. One is called pre-training and the other one is called post-training, right? The analogy I want to give you is that of a student who becomes a doctor, right? So we take a student in elementary school, we teach them all kinds of things. We teach them math, we teach them physics and chemistry and everything like that, English, all the languages. Then they go into college, then they go into medical school. And when they go into medical school, we give them a degree, we call them MBBS. And at that point, they are a doctor, but they can heal people, they can actually look at diseases, they can actually treat people, but they are still not, they're kind of raw and rough around the edges, right? They have not specialized yet. You would not bet on an MBBS doctor to do a heart surgery for anybody or put them in specialized positions. That is the first step called pre-training. So if you think about this first step called pre-training, it creates a model, an AI, that is actually a raw AI model that can actually perform these predictions, that can actually give you good answers, but it may not be very well suited for specific needs. Remember the question that I asked? My question was, explain the first law of thermodynamics in simple terms, or explain Newton's second law as though you're explaining it to a 10-year-old. A pre-trained raw model would probably explain just the law. It would say Newton's second law is force is, equal to mass times acceleration or directly proportional to the second differential of, distance or something like that. But it may not be able to explain it exactly like how I asked it. Then there is a next step called post-training or fine-tuning. This is kind of doing an MD or an MBB or an MS, for this analogy that we took of this medical student. So we take this medical student who has a lot of knowledge and we then have them do a specialization. And they use that knowledge and they specialize in specific things. And after that, they're able to perform like the things that you would want them to, like a surgery or a surgery on children or so on and so forth. So those are the two big steps. And I'm going to dig into a little bit more just so that like I give you a little bit more depth. And I told you this is all about data and sentences and like words, right? But how does computer understand words? The humans, as we understand words and we understand meaning, but the only thing computers can understand is numbers. in binary form. So the first step of pre-training is tokenization. It's what we call tokenization. So imagine there is a sentence called "the cat sat on a mat," right? We take every word. In this case, let's just, for simplicity, assume that every token is the same as every word. Sometimes we may split a word into multiple tokens. So, for example, if the word is singing, we may split it into sing and ing, the thing that indicates a verb in some tense. So for now, let's just say that it just splits it into these tokens. And what we do is we take these tokens and somehow associate it with a set of numbers. So the word cat got associated with a set of numbers. We call this a vector of numbers. The word sat gets associated with a set of numbers. How this set association happens is something that I'll briefly touch upon. But for now, just work with me. Just imagine that this happens. So we give the computer these representations. We say, here's the sentence, and for each part of the sentence, this is the vector of numbers that you need to understand. Now, suddenly, once you give numbers to these things and that representation, you're now able to cluster together and assign meaning to it. So now you will observe that, like, once we have these representations called embedding vectors, just for the sake of argument, just understand these as just these numbers. You will see that, like, where these numbers will lay in n-dimensional space will actually cluster together for similar words. So a word like cat and kitten would appear in one part clustered together, whereas a word cat and a word car would be farther away. So which means that cat and kitten are somehow similar in meaning, and the word cat and car, even though alphabetically they are closer in a dictionary, these things may be closer to each other, in this embedding space they are much farther from each other. So this is how we teach the computer that, like, these words are related to each other and these other words are not related to each other. We do this for millions and millions of words. Every single word that is part of your vocabulary goes through this thing, right?
How
But
many
now,
be there for each vector? How many numbers can be there for each vector?
that's a very interesting question. So the total number of numbers here is called the dimensionality of this vector. And it can be as much as little as 256, 256, or as much as 13,000,
Oh,
right? And how do we pick which number we should be at really depends upon how big of a model you're trying to build. Some of these models these recent models have billions of parameters. Each of these numbers you can assume is called a parameter. And so imagine if each word has 13,000 numbers, depicting that number, and then there are thousands of words, then just the number of numbers are in the millions. And then there are other parameters that together form billions. And so, for example, Llama, the latest Llama model has 405 billion parameters, with billion is 10 to the 10 raised to 9. So it can be a very, 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 very long list. And every number actually somehow associates a quality of this word, right? Now, these numbers are not human parsable. So if I give you an actual number, you will not be able to look at this and say, oh, what is this 0.22? Does this refer to an animal? Maybe, it may be not. It is actually not designed for human readability. It is designed for computer readability, or the association in computers. So essentially, right, once you associate these numbers, we can do very interesting things like this. And this is a very classic example, which is why I picked this one. So you can say that a vector of a king, which is the set of numbers denoted by a king, subtract the vector of a man from a vector of a king, and add the vector of a woman, and what you result, it will be the vector or the set of numbers that approximates the number that the word queen has, right? So if you think about it, the subtraction of these two vectors, vector of king versus vector of a man, somehow may represent the aspect of royalty, right? A king with the gender taken out is just some royal thing, right? So it could be a royal man or a royal woman. You don't know, but it's like, because it's a king, it's a man, and you take out the vector of a man, what you're left with is just this aspect, this element of royalty. Now, if you add the vector for woman, then you get the vector for queen, because if you add royalty to a woman, you get a queen, essentially. Now, of course, this is not exact math, right? So if you actually look at some examples and look at these numbers, they will not add up exactly, but they'll be very close, actually. And you can do the similar math. So if you can take the vector for a son the word son, S-O-N, son, maga, and add the vector for woman, you will get the vector for daughter. Or if you add the vector for to grandfather and add woman to it, you might get grandmother, and so on and so forth. So you see how, these words, when they're associated with numbers and represented in this n-dimensional space, you can now start to make meanings out of these things. Now, this is an example of how we build these embeddings and start teaching computers how to understand the semantic meanings of these words. Now, actually, I had like this slide is a little bit dense, actually, but like I wanted to show the different steps here. So if you take the text, she was singing melodiously, then you can tokenize or break up this text into she was singing, like I told you this one before. So we sometimes split this not fully in words, but differently, and melodious and lee, because you can add the suffix lee to other things, like she was singing horribly, like, and the ly it's indicative adjective. And so you come up with these final vectors for these. And I thought it'll be very interesting to do a second demo of today and just show you how these embeddings look, actually. So let's, this is a tool that, I think Google wrote. So this cluster of things that you see is actually words represented in an n-dimensional matrix, okay? And I give you this example of a sun. So let's just use that as an example and see if that works. So I go SON sun, I can choose this word. First of all, see, I don't know if this is big enough for people to read. Let me make it slightly bigger. You see how daughter, father, brother, wife, sons, these are all close to the word son. They have similar vectors, right? Which we can understand just in human terms, because daughter, father, brother, these are like very related to the word son. And let's isolate these points, actually. So you see how all of these things are there. So if I look at this thing, and here there is son, and then I could say something like daughter is in that direction, right? Then I can actually say something like, let me see if there is brother and if there is a word sister somewhere here. Sometimes it's there, sometimes it's not. Well, there's grandfather. I don't know if I can find the word grandmother here. But if we do this math, you can see sort of the words and the direction in which the female of the form of that is present. So if son is here and daughter is in that direction, then you can say that I can take that vector and add it to another vector that represents a male, and most likely you will see you'll see the female form of that word occurring in that space. So you can use this tool actually to sort of, look at what words are close to the other one. So for example, if I say, if the word is zero, then wait, I'll show all data, show zero. Then the other words that come 2, 5, 7, 4, 8, these are all numbers, right? Now, remember that the computer does not know that these are numbers or this is a relationship, or it has no understanding of the actual word. All it does is the representation in numbers, and it automatically arrives at this conclusion of like what words are similar and what words are dissimilar, right? So I hope you're starting to already see how we can start to teach the computer some facets of the meanings of these words. So let's continue this thing. I told you that like there are two steps, pre-training and post-training, right? And so this is basically where all of this language learning happens, right? So what we do is we take this simple example that I told you, the cat sat on a mat. But now imagine that I take a massive data set. I take all the books in the world. I take all the articles I can get on the internet. I take every website that I can get a hold of. I take every piece of code that has been written and published online, and I pass it through this learning machine. And slowly it starts learning to predict the next word given the previous word and some context, right? So in some of the models that we use trillions of tokens, trillion is 10 to the power 12. And we use trillions and trillions of these tokens to train this machine. And there is no human supervision. All we do is we tell this thing, here's the first word. What is the second word? Can you guess that? And if it guesses wrongly, we take the error and then we feed it back. And we say, here's your error. It's a little bit like how humans learn things. When we do things, we sometimes get it wrong. And when we get it wrong, we say, oh, I made a mistake. And you see what I could have done to make it right. And you try to correct it. The next time you may again get it wrong, but then you correct it and you correct it and you correct it. And like you do it thousands of times, you're an expert. That's the person who's called an expert in something. So the same way we train AI, it's actually very, very eerily similar. And so, for example, I tried this the other day. I said the energy of a photon is, and by the time I was done, it gave me the equation E equals h times nu, where h is the Planck's constant. And so it is surprising that it actually learned it. But surely this LLM has been trained on some physics book or a set of physics books and articles where this equation is found. So obviously it is able to do this prediction. So by this, it also learns the structure, it learns the grammar, it learns facts, it learns logic and coding patterns, not just facts, but it actually learns grammar for this thing. For example, if I say, this is a book, or if I say this is an book, it knows that an cannot be used here because it's an article, and what follows there should be a vowel. But it doesn't actually understand language. It is just the fact that it has gone through so much data, it knows to associate this correctly, right? So it's a little bit like, I put this comment down below. It's a little bit like if you take a person, if you take a student and give them every book there ever is on thermodynamics and tell them just go read all these books, right? But they've not truly understood anything, but they would still be able to answer a bunch of questions because they've read all of these books. They may not have any true understanding of it, but they have been given all this data. This is exactly what an LLM is after this pre-training stage. It is a raw corpus of information that understands context and is able to answer questions. This gets a little technical, but I'll go very fast over this. This is actually sort of how the learning process works. I told you that, this is the input. It goes through a bunch of stuff where there is weights and biases. It does a bunch of matrix multiplications. And at the end of it, it comes with some predicted output. And then we see the output of it and we see the expected output. We compute the error and then we back propagate these results. We put the error back into the system. And then it does this over and over and over millions and billions of times. And it finally ends up with all the correct weights and all the correct biases here. And every one of these numbers is called a parameter. And this is kind of how a neural net is trained. But let me actually talk about this other important concept in training in AI, right? Remember, I told you context is important, right? So let's assume that you have a mystery novel, and in that mystery novel, you say you're talking about two characters, and you say A and B were going here, and B did this, and C came, and D did this, and blah blah blah, and finally you say, this is why everybody knows who the thief was, right? And so if we are humans reading this book, you're keeping all this context in mind. You're saying, okay, what happened to this person? Okay, next this happened, the next this happened, and then this happened, and then this happened. So at the end of the book, if there is a sentence, and that is why we knew that the thief was dash, a human can predict and say what that name is because they have all of this context. They have read this entire book. And so there is this algorithm called the transformer that was written by a gentleman called Vaswani and other people in Google that actually helps these LLMs understand context. So this is a very, very important thing. Without context, it's very difficult to predict anything because you may have many different things you can predict, but based on that context, only a few things are correct predictions. And so this transformer is another thing that you should know as the key element in training an LLM. So what a transformer does is it helps understand context and capture long-range dependencies in the text, which means that at the beginning of a page, you could have talked about something. At the end of the page, you're referring to that concept. And you should still remember this as a chain of thought. And this algorithm called a transformer helps do that. So with all of this, after having done all of this, an LLM has been trained, right? So this is the output of it. So if I now have a word called jana gana mana, and then I give this to the model, and the task is predict the next word from here, then what it actually does is it outputs a prediction, which is a probability distribution, right? It may have a whole bunch of predictions. It says for the word adhinayaka, it may give a 95% chance the next word is adhinayaka. The next word, maybe Bharat is one prediction, but it only has a 3% chance of being correct. Namaste could be another word. Dhanyavad, like completely unrelated words. All of these words are in the vocabulary and everything has a probability distribution. And so we just pick the most highest probability word. So So that's how, because of the training that happened in the previous steps that I just explained, if you feed this thing Janagana Mana, it is very likely to pick Adhinayaka. But an LLM that is not trained very well may not actually pick that. It may pick some other word and then it may just get it wrong. But because we tend to train this LLM with billions and billions of tokens, it most likely gets it right, and it feels magical because we are thinking, how the hell did it know what this is? Because I've never taught it the Indian national anthem. Now, think about this being word after word, right? You give 3 words, it predicted the 4th word, Adhinayaka. Then maybe you go Janagana Mada Adhinayaka Jaya He. Then, if you look at the prediction list, the word Bharat could have a 99% probability of being predicted, right? So this is how word after word after word after word, and AI actually predicts this entire sentence and constructs all these sentences to you that seem logical. Now, after having done this, remember, at this point, we have this student who has done their MBBS, and they're a doctor, and they're able to do what we just saw them do, which is do some predictions, right? They get a bunch of things right. They're a doctor, they can treat people, but they're not yet specialized. So then the next step is called post-training in an LLM. So again, let's go back to the 2 steps that I said. One was pre-training, one was post-training. So the pre-training is what we have just talked about so far, and post-training is a model where we teach the LLM specific things. We say, okay, so here's a question, here's the answer. We tell it, this is the question and this is the answer. We see what it predicts and we say, oh, you predicted the wrong thing. Again, we give it the error correction. And then sometimes humans are involved here. Actually, there are human labelers who go in and say, oh, your prediction is wrong, or your tone is wrong, right? Remember, if you ask ChatGPT that I have a lot of stress today from my work, can you give me a few techniques to overcome the stress? ChatGPT would strike a very friendly tone, and it would strike a very comforting tone. How does it know to do that, right? That happens in post training. So we teach the LLM that, like, if you look at a situation like this, it's a situation of stress, and so you should take a tone like this. You should not take a very bad tone or whatever. We slowly start teaching it tones, and like we teach it like how to be helpful in a particular set of scenarios, etc. And that is post training. So after pre-training and post-training, you have the final LLM that we use, right? So one last slide on this, and I think like we can move on, which is essentially, this is kind of the question that I asked ChatGPT before. So we said, explain Newton's first law to a 10-year-old. Now, first step is we use this tons of training data. We train this LLM, pre-train this LLM. But after pre-training, it only has a very dry textbook definition of what you're asking it for. It'll say, Newton's first law states that an object at rest stays at rest, an object in motion stays in motion, unless there is an external unbalanced force. But remember, we asked it to say, teach it as though you're telling a 10-year-old. So then, but because of post-training, it now knows that like it needs to strike a friendly tone. It needs to follow these instructions, and it needs to adapt to specific things that we are asking. And sure enough, look at this definition. It says, oh, Newton's first law means that things tend to keep moving and they'll keep doing what they're doing unless somebody comes and does something to it. So this is really adapting it to that the 10-year-old.
Excuse me,
So I
how,
have some,
how does
yes.
it recognize the 10-year-old? How does it set the standard for 10-year-old?
That's a very good question. So I don't think it does not actually understand what a 10-year-old is. But during this stage, the post-training stage here, let me go back to this previous slide. During this post-training stage, we said this human feedback. So it has been provided this feedback that like if you are asked something that is age appropriate, then so, simplify if age is low, right? Is something some human or some labeling data has told it. And so based on thousands of such samples, it knows that, oh, if you're saying 10-year-old, that is a low age. And so I should use terms that look like they are simple terms instead of complicated terms. Okay, so now I think we have talked a lot about how AI is built, right? So I just wanted one full slide to summarize this because I know it's like we've gone through very fast. So just remember 3 things if at all you want to carry something away from this. Number 1 is that AI does predictions and LLMs are next word predictors. That's what they are. Number 2 is that there are 2 stages to training an AI. One is pre-training, and then the other thing is called post-training. The pre-training stage is building foundational knowledge, right? Go back to my example of like training a student with a whole bunch of books and data, but they don't still fully understand something. They can regurgitate something from these books and they may seem very intelligent, but they don't truly understand many things yet, or they're not specialized to some tasks. And post-training is where you want to specialize them, but you also want to align them with human values. For example, we don't want LLMs to output something that are not savory language or that are hateful or things like that. And we train the LLMs to not do those things. And that happens in post-training. And inference is actually the usage of the model. That the query that I ran is called an inference. You can actually ask it a question and it gives you an answer. And so this is basically the three things you need to take away from this section. So now let's spend maybe a few minutes on AI in scientific research, right? And AI in learning and education. So remember that like now at this point, you have this thing that can ingest a huge amount of data and actually give you something very, very useful. You can actually make it do inferences. You can ask it a question and it'll answer something that seems right most of the time. I'll get into that in just a second. But for now, let's assume that it does it right. Scientific research happens mostly in these four steps. You have a hypothesis. Somebody comes up with a hypothesis that I think that the speed of light is a constant. And then you may or may not have experiments. You may have a thought experiment or you may have a true experiment in the lab. And then you have a bunch of data that you need to analyze rigorously. And then you form your insights at the end of the cycle, right? AI can help in every one of these steps, right? AI can be an accelerator in every one of these steps. It can actually give you new ideas in every one of these steps. You can discover things much more easily and much faster. You can actually do data analysis in the way that you did not see. Remember the story that I started with of this game called Go and the move that AI made that nobody thought was appropriate? And nobody, even the expert, was thinking like, why would you ever make this move? But it made that move that was very unconventional. That could be the spark of an idea that AI gives you because you just did not see that pattern, but AI saw that pattern. In all of the training that the AI received, it could have seen this pattern that we maybe failed to see. So this is kind of how data analysis performed by AI can give you insights that you did not know existed before. And of course, it can actually do literature reviews and collaboration and stuff. Now, I'm going to give you some examples of how this did it. And I'll also do a demo at the end of it on how a researcher can use AI tools and how students can use AI tools. I'll go to the next slide. So AI in scientific research, this slide is on cosmology, right? So it's very, very interesting example. So in cosmology, we have all these like telescopes, like the James Webb telescope, the Hubble telescope, like all of these things that ISRO sends a bunch of probes into space. And there is an enormous amount of data that keeps flowing in, right? So there is no dearth of data at all. But the problem is that this data comes to you and you have to have a lot of training to see a little smudge and say, is this a galaxy? Could this be a spiral galaxy? Is this an elliptical galaxy? Is this an irregular galaxy? Or is this just like some star, right? How do you know that? Like you can know that because you've been trained as a physicist or like as an astronomy person for such a long time. But AI can help you do this and because it is trained on all this data. And this very interesting example here. Remember there is this neural nets that I told you about. Let me just quickly show you this slide. This neural net that I showed you, there is a kind of neural net called a convoluted neural nets or a CNN, right? It's not the news channel CNN, it just has the same name. And that CNN is actually used to train a neural net to figure out if something that it's looking at is a cat, right? So you can train it to say, these are all images of cats. So if you show it an image of a cat, it'll be able to say, yes, this is a cat, right? Or no, this is not a cat, it's a dog, right? So now we took the same technology and used it in cosmology and said, like, is this a galaxy? Right? So it is now trained on a whole bunch of data specifically to go and like research and tell you whether this is a galaxy. Now, the job of this researcher became infinitely simple because now AI can look through all of this data and do this job infinitely better than this human person could. But ultimately, it is not replacing the human person. It's just giving them a lot of insights that you could not otherwise get. The next example is gravitational wave detection. I picked a couple of physics examples. I thought it might resonate with this crowd a little bit more. So one is like, when galaxies collide with each other or stars collide with each other, there is like gravitational waves that, come out. However, because they're so far away, it is like you are trying to hear a whisper in a hurricane, right? Which is impossible to do. It's a very, very data intensive and a skillful task. But then the way that people analyze this is by looking at signatures that represent, these gravitational waves. Again, it's pattern matching. So the AI model, if you train it enough, then it'll be able to recognize these patterns much more easily. And so there are actually places that are doing research on this that use AI, to very good effect. Now I'll give you an example from biology. This is a very, very interesting example, something that I've read a lot about, and it's very close to my heart, which is something called alpha fold. So essentially, when you look at proteins, proteins are just chemicals, as amino acids that fold in interesting ways, and the way they fold has an implication on what kind of drugs you can generate. So if you want to have a drug that you want to create for treating cancer or treating something, ultimately they want to sort of figure out how the drug reacts with the protein that it ultimately goes in and interacts with, and how that protein molecule actually folds. And this is a very hard problem. It's called the protein folding problem in biology. It's been around for 50 years. And the same company, DeepMind, that I told you created this game, AlphaGo, the game that played this person called Lee Sedol on this game of Go. They created this model called AlphaFold to do protein folding analysis. And this AI was able to figure out a whole bunch of protein folding. Now, remember again, the AI does not even know what a protein is. The AI does not understand what protein folding might mean. It doesn't have true understanding, but because it has seen patterns, it is able to do this in research. And finally, I'll give one fourth example, which is like particle acceleration. In CERN, they have a large hadron collider, and then it is helping them filter collisions. So this is like looking at needles in a haystack, right? So if you want to look at one needle in a haystack of a billion needles, then this is something that's a very, very, very tough task. But because it's pattern matching, it does it very well. So if you want to generalize this thing, and if you're doing some research, you can think of training AI models in specified areas where you know what patterns to look for, but that might either be very difficult to do by a human, or you need different insights that need to come from that data. If you have a problem like that, you can use AI in scientific research very well. There's obviously a million other use cases. I just picked 3 or 4 for the length of this talk. Now I want to dig a little bit deeper into how could a teacher use AI, or how could a student use AI, right? So can AI help you teach better, right? The answer is definitely yes. So AI can be a good teaching assistant, right? So a teacher usually uses it, a professor uses a teaching assistant. Teaching assistants can get bored, they can be tired. This is not just about using a computer instead of using a human being. That's not the point here. But a human can actually get tired in their mind and they may not see insights, but an AI definitely can, right? A professor can actually say, okay, I need to teach these 3 chapters on thermodynamics, in the next 3 months. What could be a very good lesson plan for me, right? Like, here are my students. This is the composition of my students. This is the nature of my students. And like, this is what they're good at. This is probably not what they're good at. And you want to structure your lesson plans in a particular way to be very effective. And you can use AI to get those insights, because AI has been trained on a lot of data. There's videos and there's lectures and there's notes on the internet about how to structure a particular topic, right? So AI has the benefit of having all that information. So as a professor, you can actually just use that as your assistant in saying, okay, here's my objective. I want to teach this course in 3 months, but I want to make this part simple, this part hard. My students that I have actually have trouble understanding this kind of stuff. So maybe I want visual aids in some cases. I don't want visual aids in some other cases. And this can actually help make your job very, very, easy in that sense. So you can use this as a lesson planner. And you can create content with this thing. So actually, I do this for my kid. My children are 10 and 12, and they're learning simultaneous equations and things like that. So I use AI to say, craft, 10 problems of simultaneous equations of this complexity and verify that your answers are correct. And it has, lo and behold, it just generates 10 equations for me. Sometimes it gets it wrong, but then, with a good prompt engineering, you can actually get it right. And so the same thing holds for professors. If there are lab summaries that you want to check Just feed it into the AI, and it gives you the first pass at it. It can look at the report that a student has written and say, here are the 3 areas you should focus on, right? So it's a little bit like having an assistant that makes your job easier and that helps you scale, right? So that you can focus on what the things that are more important and interesting versus like take the drudge work out. So, do you want analogies? Sometimes, as a professor, you might feel that there is a particular concept that's a little hard for the class to understand because you've been teaching it in a particular way. And you might want to break out of that mold of thinking yourself. And you might say to the AI, like, can you give me 10 different alternative analogies to how I could have taught this particular concept? And AI can come up with those analyses and those insights that you might have not seen yourself. So it's a little bit of a boost for your own methodologies of teaching. And finally, there is always this thing about giving feedback to people on their tests or on their assignments or what have you. And you can because LLMs are so good with language, they're able to parse the language that people write and then give constructive feedback on that language. And a professor can use this thing. So ultimately, across these things, I would see AI being used in teaching as a very useful aid that reduces the work that you have to generally do, but also adds value in terms of the quality of education that you can provide. Because now you can figure out for a particular type of student, you can personalize the teaching to them because now you can offload that thinking to the AI and say, give me these ideas because this is the kind of student. Maybe you've not seen that kind of student before. And then AI can be a starting point for you there. But it's a very, very intelligent starting point. So it is not just about like giving you that step number one. It probably gives you steps 1, 2, and 3, which means that you can actually achieve a much higher potential in terms of your teaching. Now, on the other hand, if you're a student, you can actually learn much better with AI. This is already happening, right? So in every school here, if children are being told to write an essay, they just go to ChatGPT and say, write an essay for me, and they copy paste. And so there are now detectors that go and say, has this been written with an AI tool? And then there is a way to kind of try to detect this one. So but then, if a student wants to use this, then one of the best ways that I personally use AI to understand things myself is because I have a particular style of trying to understand things. I am a little bit of a visual learner. I try to learn certain things in depth, certain things in not. There is a particular type of learning that works for me. And so I use AI to go and do it in that sense. So AI becomes a tutor for me who's very personalized. I can say, hey, I want to understand Newton's laws, but I'm a very visual learner. Can you create some visuals for me so that I can better understand this? And AI can do that for you. So this can enhance students' learnings. If I'm stuck with a concept, I can say, I've been trying to understand this in this way. Can you teach me other ways of understanding this? Now, see here how it connects both the teaching aspect and the learning aspect. Because a teacher can teach in multiple ways, and the student can also learn in different ways. So I think AI can be a good bridge for these kinds of cases, and of course can write faster and better. I do not obviously encourage people to go and ask AI to do their work for them, but you can use AI to refine your work. So if you write an essay, you can ask AI, can you critique my essay? Can you critique this paper that I've written and tell me the areas that I need to improve? And then AI can say, oh, here it feels like your tone is off, or here the example is not deep enough, and so on and so forth. And you can go and improve upon that. And finally, it's research. AI is an amazing tool to do a whole bunch of research. And I'm going to do a demo on that. But before I move on, there is one thing I want to say. AI is actually, sometimes people assume that AI is here to sort of replace me, or, can this be a threat to my job? I think it is true for some jobs. It can actually be, a replacement because it might do something better than they do. But especially for teaching, especially in the context where Indians know teaching, where because this is not just a job in the Indian context, it's actually a very revered thing. It is true that AI can mimic knowledge and it can teach you facts, but only you can teach judgment. You can teach curiosity. You can teach wonder. You can teach how to think. AI cannot do that. AI can actually augment you, but augment you very well, right? It does an amazing job of it, but it's not a replacement, at least not yet. So we've talked a lot about teaching and research, and I want to do a quick demo about like how maybe we could use this, right? Let's try to do this. So I did two things. I put myself in the shoes of a researcher or somebody who's trying to learn something. So I downloaded this paper by Einstein on special and general theory of relativity. This was written in 1916 in German, and somebody translated this to English. It's an authorized translation. So it actually talks about this. If you look at the preface here, Einstein says that like this is to give an insight into the theory of relativity for readers who form a scientific and philosophical point of view, blah blah blah. It's actually not that big of a book, but Einstein himself wrote this one, right? So I thought like, okay, how do I maybe I want to understand this better, and like it's been so long since I read physics, so I don't fully understand this, or I may not be able to fully grok this thing. And so, let's say that we wanted to use this, and I was a student, or I was a researcher rather, not a student. And I'm looking at something like, I don't know, some on the idea of time. So it's actually a very interesting question what time is. And obviously you know this better than I do. But let's assume that I wanted to understand this paper, right? So there is a service called Notebook LM. This is a AI, or a large language model, this particular technology is called RAG, or Retrieval Augmented Generation. So you can just go to notebooklm.google.com and access this. So let me just create a new notebook here, and then I'm going to give it this paper. So I just like downloaded this, add this thing here. So the LLM, can you all see this? Okay. So, it is reading this, it is ingesting this. Okay, it is done, right? So it gives you the summary here, right? So this is simple. But remember, what was the chapter I was on? This is called On the Idea of Time in Physics. Okay. So I can go here and say, can you please explain in simple terms the chapter that begins with on the idea of time in, what is that? Sorry, in physics, right? So I asked this question. Now it is trying to explain this to me. Let's see what it does. So it tells you, it gives you references where it was. It says, oh, Albert Einstein delves into the fundamental concept of time in physics, emphasizing that for a concept to be physically meaningful, blah, 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 it gives you ambiguity of simultaneity, the need for empirical definition, all of that stuff. So you can keep on asking questions like this, and you can try to understand this paper. In fact, I could have uploaded this paper in German, the original German that Albert Einstein wrote it in, and I could have said, explain the third chapter to me, please. And then it would explain it to you. So if you're a researcher trying to read a whole bunch of information, this is an amazing tool for you. So in scientific research, if you see all these sources here, I only added this one thing, but you could have added multiple papers. So for example, in 1905, Einstein wrote, I think, 3 major papers. You could add all of them here and then say, give me some insights into this. Or you can add multiple research papers and say, compare the findings of this research paper versus the other research paper, and then it will do that analysis for you into this thing. So it's a very, very useful tool for researchers that way. Now let's actually go into if I were a student. So I was actually looking for what I should do. I actually found this physics textbook. So this is a BSc first semester physics textbook, I think somewhere in Uttarakhand. I'm sure that like a lot of these are available online. So I just downloaded this entire textbook. And let's see if I can do, let's say, simple harmonic motion, right? It's a very interesting topic. So let's now imagine I'm a student and I downloaded this book. I'm going to take this book, add it here, and then now it is ingesting this entire physics book into this thing. Let's give it a second. Anytime here, I think. It is a pretty big book. Okay, I think it is done. So let's go and see something that we can ask it a question about. So simple harmonic motion, page 83. So let's say somewhere here. Okay. Simple harmonic motion. So let's say that I go here, it gives me the introduction. oscillatory motion, simple pendulum, spring mass system. Oh yeah, so I remember this one actually. So I think the spring is supposed to be weightless, and like there's this, it's a very classic construction. So, but let's assume that I don't understand this as a student. So I can basically say, I can go here and say, I don't fully understand this section, spring mass system. Can you please explain it? And I'm always using the term simple terms. It's repetitive, but like this is just to give you an example. You can ask any question you want. Terms with other analogies. Okay. So it knows where that is. It has actually already like parsed all this text and created those vector embeddings, and it knows what the closeness is. There it is. It says it's a fundamental example used to understand SHM. It's a type of oscillatory and vibratory motion with object moves repeatedly back and forth. Look at how simple the definitions are here. Like I think even like a school student can understand this, not just a BSc level person. So actually, let me give you another thing. So I can say, let's say that I don't understand English that well, right? It's actually a pity that like in India with all these rich languages, we still use English and not any of our languages. But let's say that I can say, can you please explain this concept in this Kannada? Let's see if it works. So it says, ಇದನ್ನು ಸರಳವಾಗಿ ಕನ್ನಡದಲ್ಲಿ wait, where is it? Yeah. ಕನ್ನಡದಲ್ಲಿ ವಿವರಿಸುತ್ತೇನೆ. And it got it. So imagine the impact this can have on students who are trying to learn this in their own languages. Imagine that if this gets really, really good, we could actually take all these textbooks and all of this information and generate information in our own languages and study in our own mother tongues. And like, there's really nothing like studying in one's own mother tongue. So this is hopefully an example of like you can ask questions too. You can actually say, well, this particular concept doesn't seem right. Like, can you contrast this with what is explained in some other source? And students can use this too. So coming back to our talk here, I think hopefully you've seen how useful AI is. We've seen how AI was built and like what it does. But I have to also tell you what AI is not, because these days I think a lot of people are looking at AI and thinking about it as like, well, this is a know-all and a be-all. I'm going to take this as an answer, and that's what I'm going to believe. But there are some misconceptions that we have to understand. So AI is actually not human intelligence, right? AI does not understand. It doesn't truly understand what it is. In all of the questions that we have asked AI about the special theory of relativity, the AI does not actually understand what relativity is. It only is able to mimic and predict. But it does such a good job of predicting based on the training data that it has received that we think it's really, really good. And it is in many times, but you should always know that it can sound convincingly human, but it's actually not human. It is not human level of intelligence. Now, there is a concept called AGI, or artificial generalized intelligence, which is going towards that, which is going towards this saying, if I give you a set of concepts here, can you come up with a concept that's not in your training data, which is what humans do. Humans can come up with things on their own, whereas AI until this point is not. But when we get it to AGI, it might, but at this point, it definitely is not. So AI is a probability engine. It's not a truth engine, right? So it actually assigns probabilities, like I showed you in one of those slides, and gives you very good answers. So just like a physics equation can model nature, but the equation is not nature itself, right? So, F equals G times M1 times M2 divided by R squared is modeling the force of gravitation across two objects separated by a distance, but it is not gravity itself. So that's exactly what AI also is not. It's very important to know that. The other thing to know about AI is that garbage in, garbage out, right? So whatever is being used to train the AI is how AI is going to be. So AI can get some things really, really wrong, but it can actually sound very, very confident of it, right? And at this point, I think it is my responsibility to tell you that every single image that I've used in this talk, because it's a talk on AI, has been generated by AI. Every single image in this, I used AI to generate, like this one, for example, which it did an amazing job of. I asked it to give me an image where AI is overconfident of an answer, and it did a great job. So when AI tells you about an answer that it confidently states is right, but it's actually not, it's called a hallucination. In the same way that we use the word hallucination, that people can just have random thoughts, AI can also hallucinate. And the big thing to know is AI has bias. So in the post-training step, we try to remove the bias from AI. This is kind of why in social circumstances, sometimes you ask it a social question based on something in society, or and when you do that, you can see that these answers are sometimes either left-leaning or right-leaning, or it has some sort of a bias in it, right? This is kind of why you also see a lot of people saying, hey, India needs its own AI, or some other country needs its own AI, because if whoever builds the AI, they're using some data to build this AI, and the AI will reflect the biases in that data that is being used to build this AI. So when AI is now being used as an inference engine for you to ask questions and get answers from, you might actually what you're doing actually is relying on that data that this person or the people who built this AI used it for. So it's important for us to at least know that biases are a thing in AI, and there is always an effort to remove biases so that answers are objective, but you can only be so good in doing that. And finally, of course, AI lacks a concept of why something is true. You can ask it if this true or something, and it'll say yes or no, but it won't know why. And hopefully by now, people have some appreciation for why not. And final slide on this is going to be, just because it's oriented to scientific research, know that when you use AI for research, or the demos that I showed you, that it can give you answers that suffer from the same biases and same issues that I just outlined. So the data quality, if the data quality is not good, your inference is not going to be unbiased. Accurate. Sometimes it's completely inaccurate, and it'll still sound very, very confident. And then there is also an effort out there to make AI more transparent, in the sense that AI can say, here's what I think and here's why I gave you this answer. So then you can refer to the sources, and you can sort of make sure that, like, okay, is this something I can trust or not? And ethics is another thing that people are talking about. What is a responsible AI development? What are some ethical guidelines? Because you can use AI to change somebody's thinking on a particular area. And so, a responsible development of AI requires that you put these ethical boundaries in place, ethical guardrails in place, and like you just make sure that it's trained in an ethical way. So that's most of the talk here. Hopefully this gave people a good understanding of what AI is, how is AI built, a high level overview of that. What are some ways that like you can use it for research and for teaching and for learning, and what some of the pitfalls are. So I'm happy to take some questions now.
Thank you very much for a very nice presentation. Now there's time for some comments and questions. Anybody would like to ask any questions or make comments, you may raise your hand and then proceed one by one. So before that, I have a general question. You said that AI is going to depend on very large amount of big data. Now, how is this big data collected and processed? From where does it collect the data? How is it processed and selected and stored?
Yes, that's a good question. So the data is actually the data that we supply for training is the data that's available across the internet. Wikipedia is provided into it. Every single web page that you can get, every PDFs, all the books, or everything that has been digitized. So essentially, these large models are built with as much data as we can possibly get. And so that's why there's trillions and trillions of tokens that go inside. However, I think so that's what the big data is. And like I said, our ability to actually process that much data has improved in the last like 10 to 20 years, which is why we're able to do that. But when we pass this data into this training pipeline, it is actually cleaned in a particular way. The data cannot just be passed in its rough form. So there is a pre-processing that is done, in order to supply this data in a way that works in this case. All of this is very computationally very expensive, but that we do that because that is what ultimately dictates how good the LLM becomes. So if you think about what data, to your question, is used in training, it is everything that you see. It is all of the websites that you possibly can come across, all of the Wikipedia articles, all of the books available online. So essentially the entire internet.
All right. Okay, thank you. Dr. P.K. Aluwalia, would you please ask question? Unmute and ask. Yeah. Okay, please ask. You have to unmute. You're muted.
Me. Okay, all right. So thank you. Wonderful talk, I would say. And it was very interesting. You brought it down to a level where it really made no lot of sense to the people who are sitting in the audience. I have few questions in my mind which I wanted to ask you. You know, when we are talking about AI, there is a lot of talk of it that, okay, we have physics students in our universities, schools, and colleges, for example. And we would like that they should also be trained in such a way that they can make use of AI for going into the space of workforce for AI. Okay, so what would you really suggest? What kind of curriculum can be designed for these kind of possibilities, say for subject specific, trainings, but that should also make them ready for the employment market?
Yes, sir. First of all, thank you. I think this is an interesting question. There's a couple of answers that I might have. One is, as students, when you want to learn AI, at the moment, there's an interesting thing that people are saying, that English is the new programming language. So how in the past for computers you had to learn a computer language like C, C++, Python, Java. Without that you will not be able to do that. Now just English is the language. Natural language is how you can deal with computers, is what they're saying. However, AI is not yet, the state of the art at the moment is not yet so good that I can just ask any question in my own terms and get exactly what I want. There is something called prompt engineering that has grown into a discipline, which essentially is about how do you actually use AI in the best possible way. And it's truly not engineering in that sense of like getting an engineering degree. Anybody can use it. So there is the first part of my answer is that like students, specifically will need to know how to leverage AI the best way. And there are many courses online and YouTube that kind of teach that. I think it's an essential skill for people to have today on like, how can I use one of these pieces of software to my advantage? It can help you learn, it can help you get insights, it can help you do all of the things that we just discussed in the talk. So that's one part of the answer. The second part of the answer is I think that the accessibility of AI tools is also getting easier. For example, at the moment, still, it's not that easy for somebody who's not a computer scientist to take one of these models that's an open source model and train it to do something that you want it to do. As an example, if you're working on a physics problem and you want AI to apply to that domain or to that problem, it is not very easy as a non-technical person to sort of do that, to take this open source model and adapt it. But those tools are also improving and becoming easier to use. So I think that will be the other area that I would emphasize that people go and read up on. Luckily, there is a lot of data on this online. In fact, AI is one of the biggest growing fields on YouTube in terms of like how much educational material there is. And I think forums like this is also places where you can invite people who can come and teach small portions of it. I'm happy to do it at some other point of time myself on certain specific areas where as a non-technical person, you can take some AI tool and adapt it to sort of your usage. So I think that's the other thing. Finally, I feel like at the end of the day, AI will become as much part of our lives as computers are a part of our lives today. We don't think of computers as replacing some part of our life because that's our baseline. We always assume that there is a computer to do this work, and my work is on top of what the computer already does for me. And I think that's how AI is also going to become. And so I think there is the third part of my answer is just adaptation to that. So in terms of a curriculum, I don't think that there is anything structured available right now yet, but a combination of what I just said is something that we can string together from sources available online.
Okay. On to Dr. Mahesh. Would you unmute your question? Unmute yourself and ask question.
Yes, sir. Good evening, sir. To the resource person in USA, and good morning to everyone here in India.
Okay.
I would like to know, there is you are using notebook LM uh, google.com to give an example for a physics. It was excellent. But I would like to know, is there specific AI platforms for different technological, scientific or technological domains? For example, for physical science, for example, physical metallurgy, for example. Is there something like that, like a notebook, or it is a general one, notebook LM?
That's a very good question. So Notebook LM is a example of something we call RAG, R-A-G, or it is called Retrieval Augmented Generation. What that means is, remember I told you that the LLM is trained on a bunch of data, right? But the document that I provided may not be part of what it has been trained on. So let's assume that the document is not this physics document, but it's a manual for a pressure cooker, right? And you want to train a customer service agent so that they can answer all the questions about this particular product, right? So that is a case where you would use something called Notebook LM, like Notebook LM, because you can say, here's like an additional piece of data, which in this case is this PDF file, right? And now answer questions based on this, right? So this is called this is a tool for something called RAG or RAG or Retrieval Augmented Generation. This is not a specialized tool. This tool is only taking some data and answering questions on that particular amount of data. But specifically, to your question, the answer is yes. There are many tools that are specifically available for specific reasons. And one way for you to go look at it is if you go into ChatGPT, for example, and you can actually go into GPTs here, right? And then you can see all these plugins here. So, for example, this one is a research plugin, SciSpace, right? Wolfram is actually a plugin for doing a lot of math computations, right? Canva is a plugin for design. There's even an astrology birth chart, right? If you want to do somebody's kundli, then you can do this plugin, I guess. So things like that. So so the answer is very much yes. DALI is a very good plugin for doing creative stuff. So you can generate images and you can generate like a lot of videos and things like that. If you are into writing, these are a set of plugins that you can use for specifically helping writing. So these things specialize in making something a lot more narrative or so on and so forth. And these are for presentation. And there's actually like an infinite list of this. And this is only in ChatGPT and only the ones that they are surfacing here. But just to answer your question in a very generic way, absolutely. And that's a very good question, because if you have a specific thing, very highly likely that there is already somebody writing a plugin for it. It's a little bit like these are the apps of today, right? So when mobile phones came out, you remember that there was an app for everything. If you want to book a ticket somewhere, there is an app. If you want to go see a movie, there is an app. In the same way, now there is an app, there is a plugin for pretty much every AI scenario.
Okay, iPhone. I don't
So
know.
it is just typing in Google, explore GPTs.
We'll move on to other questions, sir, please. iPhone, I don't remember what is the name. So please unmute yourself and ask your question. iPhone.
Somshekar.
Okay, person. I don't know the person name. iPhone is there. That is the name.
It's Somshekar.
Okay, please ask your question, or we'll go on to then Professor Kenneth.
Sir,
Okay. Kelly.
sir, congratulations. Nice presentation. So, how do you relate artificial intelligence with machine learning?
Yeah. Thank you very much, first of all. Machine learning is a tool for artificial intelligence. You can think of artificial intelligence as being the overall umbrella that we talk about. And in order to sort of achieve artificial intelligence, you use many techniques. And one of the techniques is called machine learning. Machine learning is perhaps the most crucial of all of those techniques. And that's basically the difference in both of these things.
So Kenneth, please.
Hello.
Mute yourself. Unmute. You are muted. Okay.
Sir, what is the difference between artificial intelligence and artificial general intelligence?
Yes, AGI is a very interesting thing. So, like I said, one of the things I mentioned is that an LLM can answer things for you based on what it has been trained on. So the training data, almost restricts what it can do for you, and it is not able to think beyond it, so to speak. Within the training data, it can come up with like really good insights and things that you could have never seen yourself, but it is not generally truly intelligent. And AGI is an effort to sort of see if that is possible. in some sense, can it actually mimic human intelligence or try to mimic human intelligence is the AGI effort.
Okay, Professor Kenneth, please ask the question.
I think all this depends on the input data. For example, you see in India, we want to know something from the traditions of a village, etc. If the data is not available, then AI does not work, right?
Yes.
So we have to wait for all the information to be fed, or the AI should get it from somewhere from the web or somewhere
That
from the
is,
book, etc. Right?
yes, that is correct.
That's a
Actually,
limitation.
that is exactly right. I will say two things about this. Number one, you're right. So the more data AI is used, in training data is used, the better the LLM or the AI can get. And so if there is a domain in which this data is not at all there, then it is very unlikely that the AI will give you something useful. However, the AI can make some inferences based on things that it knows from the data that it has. So, for example, you may not have something that is a particular custom in a particular village in India that is remote that nobody has any data on. But let us say that, but there could be somebody's article that maybe guesses that, hey, there could be people in India doing this, etc., and it'll pick that up. So these are cases where you may see that, like, okay, it may not have the exact data, but it is actually giving you something close because some other data points to it. Number two, these are some cases where AI hallucinates. It may not sometimes tell you, I don't have the answer. It'll just tell you something as though it is the answer. And that is the thing you should be very careful about. So that hallucination is very important. This question is also important because I want to mention one other thing. There is one area today where you can see this thing being affected very strongly, and this is translation. So if you take a part of Chinese text or if you take French text, and if you want to translate that to English, the translation is very high quality, very high quality. That is because there is an enormous amount of Chinese text and there is an enormous amount of French
French.
text that already has translations to English, that already has translations in all these languages to and fro. There are English translated to French, French translated to English. But if you take Indian languages, even vastly spoken Indian languages, Tamil, Telugu, Kannada, all these things, there is still not a lot of information. There is not a lot of technical information written in Kannada where you could even train these things. So, for example, that's why translation is okay, but it is not as great in Indian languages yet. So the data definitely matters. Yeah.
Because on the other day, somebody was telling that when they asked the AI the name of Sir C.V. Raman's wife, it gave a wrong name.
Yes. That's an example of hallucination. I think it does this very often. Sometimes it gives you can ask it like, hey, should I buy this stock? What do you think? And it may say, yes, absolutely, you should buy the stock because this company is doing really, really well. And you may, the answer, because because LLMs understand language, the language construction is very good. So you may think that that is very authoritative, but it may not be.
I have a rather small technical question, if you don't mind. So when we try to figure out the weights and parameters, we make use of the so-called gradient descent method, I've heard. While doing that, how do we
Correct.
do the gradients when we have discrete number of parameters? So maybe million, but they're discrete. How does one arrive at the gradient descent in that particular case of?
Yes, I think that's a very good question. So there is a learning rate, and there is, its own sort of set of, techniques. There are many ways, many techniques in gradient descent. And I think that, like, even discretely, when you choose the path of descent, you can actually choose to say how quickly you want to descend in that path and how much of the local minima or the local maxima you want to explore. And so based on that and based on the learning rate that you want to use, you can come up with like a good enough approximation of gradient descent there. But it is actually, given that it's one of the core techniques that is being used actually, so it has its own sort of domain of research where there is so many different techniques of doing that. And each technique applies in a particular scenario where you have certain parameters in particular ways.
Okay, thank you. Professor Nagaraj, would you like to ask any questions? Otherwise, our General Secretary P. Nagaraj is there, so he would ask any questions or propose a vote of thanks. Professor Nagaraj, P. Nagaraj.
Hello.
P. Nagaraj. P. Nagaraj. I think he has muted himself.
Hello, sir. May I ask one question?
Please.
Sure.
Yeah, good afternoon, sir. Actually, we are heading towards, I have just, one queries in my mind. Since we are through from perception to generative to agentic, generous, and then probably in the coming years, physical AI. So this AI technology, am I audible?
Yeah, please ask.
Does it creating a dependency on the humans? Could you please throw some insights on it?
Sorry, can you repeat your question? Is your question, do humans start depending on AI or the AI's dependence on humans?
No, no,
Can
no.
you?
Humans are being, creating AI technology is creating a dependencies for the humans. So whether in maybe after 20 to 30 years, the humans will start depending on the AI technology and losing the fundamentals of all the technology or the knowledge. So what could be a future stick, the things? Could you please show some insights on it?
Yeah, it's an interesting question. I think it's a little philosophical as well. I think the answer to this question actually is that I don't think people know yet. That's truly the answer. People are trying to predict this. If you look at this, the immediate question is actually, will AI take my jobs, right? So AI actually today writes code better than a lot of junior engineers or junior developers write code, right? Today, like as it is, right? There is a tool called Cursor. You can use that. It will write code much better than a new engineer. So already many companies are saying, well, why should I hire new engineers? Maybe I should just use this tool to write the code for me. So there is a question about how AI is displacing jobs or creating new jobs or what have you. What is the effect of that on society is like an immediate question that people are asking. And I think that like there are many things like this actually. Sorry for the longer answer on this, but like just want to explain it a little bit more. Like for example, if you take lawyers, right, in the United States at least, the law is a very very lucrative profession, and so you could go to a law firm and you say, well, I want you to write this brief, and there could be five paralegals who write this brief, and each one is charging hundreds and thousands of dollars, and they take a lot of time to do it. But AI can write a big chunk of it very very quickly for $20 a month. So then the law firm is looking to see, should I have all these expensive paralegals and lawyers, or should I just like have two or three and then use AI to supplement this thing, right? Why should I not do this? So the immediate question is there, and it actually is a question that can affect society in a true way, because when job displacement happens, then you need to see what it is. But if you go back 10, 20 years or so, 20, 30, 40 years maybe, when computers were becoming the thing, people were asking similar questions. Oh my God, like if computers become the new norm, will humans have jobs or not? Like, are we so dependent on them? But today you don't think about it that way. When cell phones became used, the same thing, right? Which is like, I don't remember anybody's phone number today, but 20 years ago, maybe I did remember people's phone numbers, because now I know that it's on the cell phone. I don't need to remember it. So there is an aspect, I think, of yes, I'm dependent on this AI for doing certain things, but that dependence is okay because it just does my job for me, and now I do things outside of it that is useful for me and value adding for me. But to your question, which is like the philosophical part, is like, does this ultimately make us better? For example, can I be a good writer because AI is doing all the writing for me, and my writing skills are not as great as before? um, it's, I think, partly maybe true, but partly maybe you pick up other skills that are actually some things that you can't do today because you just don't have the time for, or you don't have the base that you need. You spend all your time doing this. Now if AI does that for you, you may pick up a skill that is even higher or something. So it's a non-answer, honestly, for your question, because I don't know is the true answer, but I actually probably will posit that nobody knows the exact answer as to what is going to happen. But one thing is for certain, that like not only is AI going to penetrate every single field. As an example, you could be a radiologist reading X-ray images and MRI and CAT scan images today, and you're making a lot of money, and you are like very busy, and you're very well sought out. But a computer program can do that for you, right? Does that eliminate the need for the radiologist? Is unknown, right? Because ultimately you might want that human factor, but it may make the radiologist's job easier, at least at the minimum. So what happens to this whole area of radiology? How does that change treatment of people? Is a little bit of an unanswered question at this point. So we
Okay.
should wait.
Thank you. Thank you so much.
Thank you very much. We are coming to the end of time. I request our General Secretary Mr. P. Nagaraju to propose a vote of thanks on this occasion. Professor Nagaraj.
Sir, may I ask one question? This is Dr. Yunusaba from PS University.
Quickly, please. A quick question.
Yeah. Sridhar sir, your lecture was amazing, sir. Very good, excellent, fantastic. I have one question. As a teacher like me, artificial intelligence is going to replace the teachers or what, sir, in future?
This is a good question. I actually I had like a particular slide that I do want to sort of share again in this case. So I do not think that it is going to replace teachers. Like I said, this is the slide that I think I want to show. So AI can mimic knowledge and it can teach facts. It can make your teaching job easier. It can actually make you a better teacher, perhaps, and then you can make students better learners. But I think teaching is not just about imparting knowledge or telling people what you know and making sure that they know what you know. I think it is about teaching people to judge, teaching curiosity and teaching wonder, and teaching people to actually think and be better versions of themselves and have empathy and kindness and all of those factors, which I don't think that AI can do, at least not today. I have to get that clarification because I myself don't obviously know. I'm not that big of an expert to know how exactly it's going to evolve. But at the moment, it's my strong feeling that that's not the case.
Yeah. Thank you, sir. Thank you so much.
Nagaraj. Professor P. Nagaraj. I don't know, he is not there. Okay, if he's not there, I would like to thank all the persons who have participated in today's webinar. And I would like to thank definitely profusely our speaker, Dr. Sridhar, for kindly presenting such a wonderful talk on this AI and its applications. I would also like to thank Dr. Raghavendra, M.K. Raghavendra, who has provided us technical support in conducting the workshop. And thanks also due to Professor Kenneth for making this webinar possible by contacting the speaker and arranging the talk. So thank you very much, all of you. Now we are closing the meeting. We'll come back next week. Thanks a lot. Thank you
very much.
Thank you, sir. Thank you.
Have a good day. Bye.
Now we are leaving the meeting.
Problem.